right, so today we're moving on with chapter 11, and our first lesson is about permutations and combinations. And so we're going to learn what a permutation is and what a combination is. And we're going to write these formulas at the top of your assignment, so make sure that that's ripped out. I will not wait. So I've already said it. I'm going to say it one last time. Rip 11.1 out of your journal, or have your journal open to, or your workbook open to this page. I'm going to start, instead of the spell work, we're going to start with a video today.
What is the fundamental counting principle? Well, to figure out this principle, let's take an example. Let's say that you walk into a sandwich shop and they have a special that allows you to create your own sandwich. They have 5 different types of bread, 8 types of meat, and 6 types of cheese to choose from. How many different sandwiches could you make from all of those options? Well, to figure out that number, we need to start looking at the different options we have. Let's start by looking at our different options for bread. There are 5 different types of bread to choose from. So let's number them out. 1, 2, 3, 4, and 5 for the 5 different types of bread. Now let's look at meat. Well, there's 8 different types of meat to choose from. So we want to write out all of those options. Perfect. Now for the cheese. There are 6 different types of cheese, so we write down all of those different types. Now that we've written out all the different types of each bread, meat, and cheese we can choose from, let's see if we can play around and figure out how many different sandwiches we could make. Let's start out with the bread. Let's say that we choose this, type 1, the first type of bread. Well, if we choose the first type of bread, how many different meats could we have? 8. There are 8 types of meat. So we could pair the type 1 of bread, we could pair that up with any of the different meats that we have. So we draw a line to each of the different types of meat. Great. Now what about the cheese? Well, let's see. Let's say we chose this first type of bread, and then we chose this first type of meat. Well, if we choose this first type, then there are 6 different options for cheeses. So we draw a line to each of those. Now look, if we choose the first type of bread and the first type of meat, there are 6 different sandwiches we could make. Now that's just talking about the first type of bread and the first type of meat. Think about all the different options we'll have if we choose the other types of bread and all the other types of meat. That pairs up with the different types of cheeses. Wow, there's a lot of choices here, and this could take a long time to write out how we're doing it. Fortunately, there's a shortcut to finding out this answer. It's called the fundamental counting principle. So let's take a look at it. Let's say that we have an event. We'll call it event M. And this event can occur m number of ways. Now let's also say that this event is followed by another event. We'll call it event N. And this event can occur n number of ways. Now, if we want to figure out the total number of ways these 2 events can occur, we use the fundamental counting principle. To do that, we take the ways that these events can occur and we multiply them together. So we take m times n. And we get m times n different possibilities. So now let's take this and look at another example. Let's say that we roll 2 6-sided dice, one right after the other. Well, when we roll the first die, we have 6 different options for what number comes up. So we have 6 different ways. Now when we roll the second die, we have another 6 different options. So we write that down. Now to find out the total number of options we have, take the 2 numbers and multiply them together. We get 36. So if you roll 2 6-sided dice, there is 36 different possible outcomes you could have for what comes up. Now let's take this fundamental counting principle and apply it to our original example. Here we have 3 different events, choosing bread, meat, and cheese. So we need to figure out how many ways we could do each of these. Well, let's see. For choosing bread, we had 5 different options. So that's 5 different ways. We write that down. Now for the meat. Well, there are 8 different types of meat, so that's 8 ways, 8 possibilities. Now, if we just think about the different options for bread and meat, we would need to take these two numbers and multiply them together. We would get 40. That means we would have 40 ways, or 40 possible choices, to combine the bread and the meat. But what about the cheese? We need to include that too. There are 6 types of cheese. So, in order to get all the different sandwich possibilities, we need to take 5 different types of bread times 8 different types of meat times 6 different types of cheese. We get 240. That means that there are a total of 240 different possible sandwich choices from what we have in our problem. Neat. Now notice, in our definition, we were only working with 2 events. And in our example, we were working with 3 events. With the fundamental counting principle, it doesn't matter how many events you have. All you need to do to get the total possible ways, or the total possible outcomes, is take the number of ways each event is occurring and multiply it together. So here, we had 3 different events. So we took each of those different ways and multiplied them together. And we got a total of 240 possible choices. So now we know about the fundamental counting principle.
Okay, so let me pause this for a second. Okay, so if you will, we just learned about the fundamental counting principle, and it just says if I have 3 pants and 2 shirts, how many different combinations can I make with that? So then that would be 3 times 2. So it would be 6 possible outfits that I could get with that. Any questions? Okay, look at 11-1 on your workbook, and it says let me do this next example first. Sorry, let's look at this first. Using this principle in motor vehicles, it says the photos show Maryland license plates in 2004 and 1912. How many more 2004 style license plates were possible than the 1912 style plates? So let's look at what they had on them. So if you look in 2004 here, they had a letter, a letter, a letter, and a number, a number, and a number. So we had letters and digits. Well, we know how many possible alphabetic characters do we have? 26. So this is going to be 26 possibilities, 26 possibilities, and 26 possibilities. And for digits, we have 0 through 9, so that's 10 different digits. So 10, 10, 10. And if we want to find out all the combinations, we're going to multiply all these together. All right, and then let's look over here. 4, 3, 6, 7 is all we have, then Maryland and the year. So that's not part of what we're calculating. We're just looking at these digits. So we had 10 possibilities, 10 possibilities, 10, and 10. So 1, 2, 3. So that's a 1 with 1, 2, 3, 4 zeros behind it. So we have 10,000 possibilities in 1912. Now over here we're going to have to do 26 times 26 times 26 with 3 zeros after it. And when we do that, we get 17,576,000. And then we know 10,000 were possible in 1912. So it said how many more were possible here? Well, subtract the 2. So we're going to take 10,000 from the 17,576,000, and we get 17,566,000. And that's how many more combinations were possible just by dropping one number and adding 3 letters. So now you see why passwords on websites force you to a minimum of so many things, because it's just exponential growth from one character or character set to the next. Any questions on this? Yes? 10? Well, here, okay, so here, how many possibilities do we have for an alphabetic character to be here? 26. How many possibilities here? 26. How many here? 26. How many characters are possible? You've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. See that? And then 10 characters there and 10 characters there. Because on your license plate, you can have any, alphabetic, 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 numeric, numeric, numeric. These are the possibilities. So you have 10 possibilities for each number that goes there. That's where the 10 came from. Did that answer your question? Okay. All right. So to get the total number of possibilities, you multiply 26 times 26 times 26 times 10 times 10 times 10, and then subtract from the 1912 possibilities. Okay, look at your first problem on 11.1. It says you must make a password for your email accounts. The password must consist of 2 letters, so we've got an alpha and an alpha, followed by 4 digits. So, digit, 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 digit. How many different passwords are possible? So, what are we going to write? How many for the first alpha? 26. And for the second one, we've got a 26. How many possibilities for the digit? 10, 10, 10, 10. So now multiply. 26 times 26 is 676. And then we have 1, 2, 3, 4 zeros. Right? So that should be 6,760,000 passwords. Everybody see that? Okay, so I'll let you do number 2 at home. Okay? And let's move on. Now we're going to talk about a permutation. A permutation is an arrangement of items in a particular order. Suppose you wanted to find the number of ways to order 3 items, like first place, second place, third place. All right. There are 3 ways to choose the first item, 2 ways to choose the second, and 1 way to choose the third. By the fundamental counting principle, you would have 3 times 2 times 1, which equals 6 permutations. See that? So when you have something, you start with n, and then you go to n minus 1, and then you multiply to n minus 2, all the way down to 1. We call this a factorial. So let me use a bigger number. If I had 9, that's n. So n minus 1 would be 8, n minus 2 would be 7, n minus 3 would be 6, n minus 4 would be 5, and so on, 4, 3, 2, all the while till you get to 1. Okay. And when you multiply all these together, this is called 9 factorial. Okay. So if I ask you to write a 5 factorial and just calculate it in your head, you would know that that is 5 times 4 times 3 times 2 times 1, which is 20. 20 times 3 is 60. 60 times 2 is 120. And 120 times 1 is 120. So we could say that 5 factorial is 120. Everybody with me there? Okay, now let's look at how to enter this on the calculator. So get your yellow calculator, and I want you to turn it on, and I'm going to first show you, because a lot of people get on these. I saw yesterday how to clear these very easily, so you can always, like in a test, you can start with a clean calculator and no surprises that somebody's messed with the settings. So if you hold your on button and hit clear, it should say memory cleared. Everybody get that? All right, now with that, hit clear and clear those words. And now this is how we do a factorial. I want you to type the number 3. We're going to do a 3 factorial. So type the number 3, and now hit your PRB button, and I've got it highlighted right there. Second row, second button, PRB. And now if you notice, choice 1 is NPR, choice 2 is NCR. That's what we're doing today. And choice 3 is factorial. So just either highlight down, use your cursor down to 3, or type the number 3 and press enter. And it will show 3 factorial on your screen. Now when it does, press enter one more time, and on the right it'll show you what the answer is, 6. Everybody good for that? Any questions? Okay, now what I want you to do is hit clear, and now I want you to do a 6 factorial and write the number on your whiteboards and hold up your answer. 6 factorial, and hold the number up on your whiteboard. Okay, you're good. Good, 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 good. Yes. Yes, yes. Everybody there? Anybody left? Good. All right, so it was 720. Now, how do we do that? So you would type in 6, the PRB button, and then type the number 3, and it comes up with 6 factorial, and then you press enter. And then it'll come up with 720 on the right. Okay, now I want you to do a 20 factorial and write that answer on your board. And this one I know you can't calculate by hand very quickly, so this will prove everybody can do this by calculator. Make sure you write all the information there. Good, 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 good. Yes, yes, yes. Yes, yes, yes. Yes, yes. Hold yours up a little higher, Tira. Yours came up a little different. Did you truncate a little bit there?
Yeah, I put like all the
That wouldn't be correct. You notice that it is 2.43 and then some more numbers times 10 to the 18th. I'd like to see that scientific notation there. That's important, okay? All right, so that's all you missed, is doing the scientific. Instead of putting the power there, I want to see that, because now we're in base 10. What if we weren't in base 10? So that means a lot. So everybody good on how to type these in? Now, what if we had something like, let's do a division. What if I had 3 factorial divided by 8? Now let's do this. Hold on. How about 8 factorial divided by 3 factorial? How do we do this? Well,
N over D first,
yeah, you could do it that way too. You could do. We didn't do it that way this morning, but that would work. The N over D is a really good suggestion. But what we did this morning, I just did 8 factorial divided by, don't press enter, just do 8 factorial divided by 3 factorial. And then press enter. So you should see this on your screen. 8 divided by 3, and then press enter. And when you do, I want to see what you get on your board. Good. 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 Yes. Good job. Yes. 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 So, yeah, you can try it both ways. The N over D works too. Good. Let's try that one more time. Do 8 factorial and then hit divided by 3 factorial. Try it one more time. And then press enter. It should be 6720. Yes. Okay, so work number 3 in your workbook quickly. And Karen, did you get it? Okay, I'm going to come get with you. So for number 3, what did we get for 6 factorial? Just 720. Good job. So it is 720, 6 factorial. Now I want to point out something on number 4. On number 4, it says 5 factorial times 4 factorial. A lot of students think, oh, well, I can just like 5 times 4. That's the same as 20 factorial. Why don't you try 20 factorial? Well, we did it a minute ago, right? And it was a huge number. Well, now try 5 factorial and then multiply it to 4 factorial. So let's... Okay, so say that again.
5 factorial, 4 factorial, and then it pops up.
Okay, so these calculators are so smart. All you have to do is go 5 factorial, 4 factorial, and then press enter. And there it is, 2880. That is the correct answer. Now you could also go 5 factorial times 4 factorial and get those individually, the 5 factorial, then multiply against 4 factorial. Now, I've also seen kids try to add these as a 9 factorial. Well, let's see what 9 factorial is. It's 362,880, so that doesn't work either. So when doing these multiplication, don't combine. All right, so type it in exactly as you see it, or do one at a time. Like do your 5 factorial, whatever that is, and multiply against the 4 factorial, or like, I don't want to say names on the video, but like you said, you can put them both together. Okay? And same for division. You're going to have to do the division. We've already done a division, so you can't simplify those just yet. Okay? All right, any questions so far? All right, let me look at a word problem that goes with the permutations. Finding the number of permutations of n items. It says, in how many ways can you file 12 folders, one after another, in a drawer? So when you look at, you've got 12 folders, and it's like, how many ways can I order these? So it's going to be 12. So if I take that 12th one and put there, that means I have 11 to work with. So then there's only 11 ways to do the rest, which would leave 10, 9, 8, 7, 6, all the way down to 1. So really, this is just 12 factorial, right? When the order doesn't matter, we're just going to, we've got 12 folders. How many ways can we put them? So it's going to be 12 factorial, which is 479,001,600. Okay? So that's an example of a word problem.
So we got like this example for number 6. So if 6 is your first has 12 Tuesdays, these numbers on 1 through 12 you can to give 1 jersey to each of the 12 members of the basketball team, and how many ways can a jersey be defined? So that's basically the same answer.
Yes. So 6 and 7 are just like this, okay? So you'll work those at home, and we already have 6 done. So basically you're going to do 5 and 7 at home. All right, now we're going to start 2 formulas. The first one we're going to learn is number of permutations. Now this is what the formula looks like, and I want you to write it at the top of your first page. So n capital P lowercase r equal n factorial over n minus r factorial. Okay, that's what it looks like. Now this is for permutations. All right, and let's watch this video.
Hi, my name is Mr. Patel, and I'm here to help you out with using permutations. So remember that a permutation is an arrangement of items in a particular order, so that's important. If you want to figure out the number of permutations, let's say we're choosing, out of a total of n items, we're choosing r, and order matters, of course. One way of doing this is to write it like that, the little subscripts n, big P, and then the subscript r. This is defined, according to this formula, as n factorial divided by n minus r factorial. Don't forget what factorials mean. N factorial is n times n minus 1 times n minus 2 all the way to 1. Okay. So let's say we have a club of 15 students, so that's going to be important. We want to choose a president, vice president, secretary, treasurer. So this is one officer. How many different arrangements are there? So if we're going to use this notation here, which of these 4 is correct?
Okay, so now we're talking about just not the total number. We're talking about we're choosing something out of that number in a particular order. So the number of permutations of n items set to arrange r items at a time. So they say they've got a club of 15 students to choose a president, a vice president, and a secretary treasurer. So how many total students are there? That's your n. So, and then the R would be how many arrangements. R stands for the arrangements. So we've got a president, a vice president, and a secretary treasurer. So how many arrangements will we have? Well, secretary treasurer is one thing. So it'll be 3. So we have 15 for N and 3 for R. So which is correct? A, B, C, or D? Or B? 15P3. Okay, let's see. I'm going to choose it. It's going to be really, really loud.
That's right.
There you go.
Well, if we just pay attention to the definition here, we see it's B. Okay, the N, well, that's the total number of students from which we're choosing. Okay, and well, there's 1, 2, 3. There are 3, so R is equal to 3. There are 3 people being chosen. So that's why it's this. Now, of course, if we want to finish the calculation, what this means, of course, this is 15 factorial over, not over 3 factorial, but over 15 minus 3 factorial. In other words, 12 factorial. Now, we could use a calculator, but of course, 15 factorial is 15 times 14 times 13 times 12 all the way to 1. And then this is 12 all the way to 1. Now notice, of course, 12 and all the way to 1 cancels. And so what we're left with is 15 times 14 times 13. And that's just 2730. So we could say there are 2,730 different arrangements. Now that's a fancy formula. There's also the alternate method, which
We're not
is just
going to
kind
do
of...
the alternate method. So I'm just going to stop it right there. So now we've got that formula put to use. So what you do is there's always going to be like first, second, third place, or there's a secretary, vice president. There's 3 things usually in these examples on the test and on this assignment. So that's what they always used to teach this with. So when you see the thing with, oh, there's first, second, third place, or 1, 2, 3 something out of a total number of something, you know you're going to do permutations. and it's always the same little formula, and that's why I had you write it up at the top of the page. Everything on the first page is the permutations after we get past the factorial. So let's take a look at our assignment. There it is again. So NPR equals n factorial over n minus r factorial. Okay, so if I had 11 students performing a math race, how many ways can those students win first, second, and third place? So what's my n here? 11. And what's my r? 3. So you got it. And then you would just plug it in. It would be 11p3 equal 11 factorial over 11 minus 3 factorial. And 11 minus 3 is 8. So you get 11p3 equal, so it's going to be 11 times 10 times 9 times 8 all the way to 1 over 8 all the way to 1. And that 8, 7, 6, 5, 4, 3, 2, 1, those cancel out. And I'm left with 11 times 10 times 9. Well, 11 times 10 is 110. And 110 times 9 is 990. So that's how you work these. Quite simple if you just let it be simple. We're only dealing with 2 formulas, and this is one of them. Okay, we're not there yet, so hang on. All right, so let's look at this. It says 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third? No ties allowed. So what's our n here? 10, because we have 10 runners. So it's going to be 10p, and how many places? 3. So it's going to be 10 factorial over 10 minus 3 factorial, which is 7 factorial. So it's going to be 10 times 9 times 8 times 7 down to 1 over 7 down to 1. And those 7s cancel out. So you have 10 times 9, which is 90, times 8, which is 720. Okay? So we've already tried the division on the calculator, so I'm not going to make you do that again. Are there any questions over this one? Okay. Look at your assignment. Now we're going to do 8, 9, and 10. So 8, right now we're just going to work number 8 together. So work number 8 and let's see what you get. And then we'll talk about it at 11. Okay, hold up your answer when you're done. And we've got to hurry because I've got one more to show. Good, 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 good. Yes. Okay, I didn't realize time's getting away from us here. All right, yes, good, 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 good. All right, so yes, the answer was 60, so good job. And then you'll do these 2 at home. And 11, what was your question on 11? There are 12 different types of pizza, so that's your 12p. And let's see, there's first, second, third, and fourth. So we have 4. So that's your n and that's your r. So, and you're going to solve it the same way. Okay, now let's look at the back side of the paper, and I'm going to give you another formula. And this one goes with the ones on the back. We're not going to have time to watch the video. Okay, here's our formula. It's NCR. This is for combinations. This is when the order doesn't matter. So it's NCR equal n factorial over r factorial times the difference of n minus r factorial. So there it is. Write that at the top of your page. And let's just work number 12 together. So 12, we have 7c2. And so we know that this is our n and that's our r. So we're going to have a 7 factorial over 2 factorial times 7 minus 2 factorial. So when the order doesn't matter, it gives you a lot of more possibilities, right? So that's the one that gives the bigger number. There's more to it. So now 7 minus 2 is 5. So now we're going to have 7 factorial over 2 factorial times 5 factorial. Well, we can rewrite that 7 factorial is 7 times 6 times 5 factorial, right? That's the same thing, right? So we can cancel out our 5 factorials. That's just another way to do that. You could have written 5 through 1 and 5 through 1 down there. Now we've got 7 times 6 on the top, which is 42, over 2 factorial, which is 2 times 1, which is equal to 21. And that's your answer. All right, any questions on that? And I know that there's an NCR and an NPR on your calculator, but you need to know how to work these. What if you didn't have this calculator, right? What if I say no calculators allowed? So make sure you know how to do those. All right, so you'll work 13 and 14, 15, and 16 and 17 is just a little bit different, but just keep working. Like that 16, it says 5 times 6c3. So you're first going to calculate 6c3, and then at the very end, whatever that answer was, you're going to multiply times 5. You see that? So don't let that trip you up, okay? Now, what happens, I got to give you a word problem. It says, when order is important, okay? When order is important, you've got the P, the permutation. When order is not important, you've got a combination. So let's look at this. Problem 5. For each situation, determine whether you should use permutation, that's where order is important, or combination, not important. So a chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. How many different ways can he select the drawings? So is this a permutation or a combination? Does order matter? What? Yes, no? Well, is there like a first, second, and third place where it has to be first, second, third? Or is he just selecting 4 things at random? So that means the order is not important. So then that makes it a combination. So when you don't have first place, second place, third place, it's a combination. Now let's look at the next one. You will draw winners from a total of 25 tickets in a raffle. The first ticket wins $100. The second ticket wins $50. The third ticket wins $10. How many different ways can you draw the 3 winning tickets? So is the place important? Yes, so that makes it a permutation. So here's the way I remember it. I think of like a mutant monster, mutation. You know, mutation, he starts out as a normal human being, he falls in the radiation sewer, and he starts turning green, then he goes slimy, and then he gets ulcers all over his skin, and he turns into a horrible monster. The order of his mutation mattered. Permutation, order. That's how I remember it, okay? So I want you guys to work through 19 tonight, so just don't do the last 2, and you're basically done. I think a lot of you are probably already done. So it's that easy, okay? And that's everything today. Thank you so much, and that concludes our lesson.